Hello and welcome everyone. I am Mehdi Mehri, project manager at ArtingGame. Here I'm going to share our experience with using ML Agent in our project. I hope it's useful for you and your team, and you decide to use ML Agent in your further or current project. This is the topic we will cover in this presentation. Let's quickly look at the topics. We're going to tell what is ML agent and how the logics is work. Then we see what kind of game prefer to use ML agent and benefit of using ML agent. Then we quickly look at how to install and run Hello World example for ML agent. Then we have 3 video example of different game we implement and test using ML agent. First of all, on September 2017, Unity first version of the ML agent was released. The purpose of ML agent was help developer to use Unity to train and use machine learning and intelligent agents for their game and use inside the Unity. The current version of ML agent is 2.3.0. The logic of ML agents is very, very simple. We have an agent. Agents take actions. Actions help agent interact with our environment. Then we update the state based on action agent takes. And we gave a reward or change state for the agent. And we repeat this cycle over and over again. With this cycle, agent learn how to play and interact with our environment and learn how to play after many steps. So based on our experience, ML agent is very useful and good for any hyper-casual that we have computation, like IO games, racing games, or stacking games, anything your player like to competition with other player or want to feel fake online games because in hyper-casual making online games is very, very costly and it's not suggested to use. Also, you can use ML agent for your enemy's behavior, like if your enemy want to chase player, if enemy reach inside the reaching area, start chasing player, or you can use for NPC AI, like in farming game, you have NPCs help the player to collect or use items or help to, like this game here, help to farming or making something. You can use ML agent for this purpose too. Also, we are not preferred to use or in other games like runner. If you have runner game, it's not preferred to use ML agent because it's very costly and don't have a very good result for runner game or the simulation game like coloring ASMR or game like this, because there is no need to use ML agent, and if you use ML agent, zero result happening. Also, it's not preferred to use in first step. If you are just on the testing step, it's not preferred to use ML agent because you don't know you are going to publish this game or not. The main benefits of ML agent is ML agent help you to modify your game difficulty based on user experience. This means if your users are good at playing this game, you can increase difficulty, or user can't play your game, you can decrease difficulty, and you can do it by internal controller or remote config. So you train many agents for each step, and you can reduce or increase difficulty on your game. This helps player increase satisfaction. They feel they are like playing online game or the competitor of the games based on their experience. So their playing retention will be increased. Also, using and creating ML agents is very, very low at price compared to online games because almost it's free. You just need a few hours to set up ML agents for your game. And it's really easy to set up because if you done it once, you can done it many times for other agents. Let's quickly look at how we can set up and use ML Agent in our project. ML Agent use Torch open source library using Python to train and learn machine learning for your agents. So we have to start using Python. It's preferred to install Python version 3.8.13 or higher based on Unity ML agent toolkits they put on their GitHub. So after installing Python, we have to create environment. Environments help Python interact with each project separately. This means you can create environment for each project, and they don't have conflict with each other in config or setting. Then we have to install pip. Pip is package manager for Python. It is just using to install Torch. We don't have anything with using pip. Then we have to install Torch using pip. Torch is the open source library to using machine learning in Python. After installing everything, we have to use ML Agent Learning package. This is connect Python to our Unity project. In Unity editor side, we have to use Unity version 2021.3 or higher for using latest version of ML Agent. Also, you need to set up these two packages, com.unity.ml agent and ML agent extensions. Then you have to write everything in C# language. Don't need to know any knowledge of Python. The other steps are technical steps. I already create and record video to show how this setup is happening, because it's different for Unity developer to set up and connect Python to their editor. Let's see the video. First of all, we are going to Unity Technology GitHub repository named ML Agents. Then we can see current version. The current version is 20. The date of the release is here. You can see installation step also in the repository. The steps I already told you. Let's start with installing Python. I download Python 3.9.11. I also show the example in Windows 10 environment. It is almost same with other platforms like Mac or Linux. After finishing Python installation, you have to open up your command prompt and type Python -V. You see there is a version, it's installed correctly. Now we have to clone the repository Unity provide to us and open up the project. It's contain 17 example of ML agent implementation. First of all, we have to create environments. To create this, we open up command prompt and type this command, Python -m, venv, and your environment's name. This is how we create environment in Python. After creating that, we have to activate this environment. To do this, you have to go to your environment folder, then scripts. Here, we head to script folders. We have to run activate.bat file, then head back to command line and type activated. This is how we activate environment. If you activate well, your environment name will appear in the beginning of the command line. So next we have to install Torch. Before installing Torch, we have to update or upgrade our pip repository. So we run the command Python -m pip, install pip, --upgrade pip. This command helps you to install pip or upgrade your current version to latest version. As you can see, it's happening very fast. Now we can install Torch through the pip. There is a command on GitHub repository. I removed the version of the Torch because it's help the Python decide which version to install. When we force, maybe it's not good for this current version and make conflict. It makes time because it's 2.5 gigabyte of size. After finishing the installing Torch, we have only need to install ML agent. This is our connection between Python and Unity. Yeah, that's it. This is how we install, and to see is everything is correct, we run this command ml agent --help. In this case, we have a little issue here. We have to downgrade our proto buffer packages to version 3.20. So easily using pip, install prototype buffer version 3.20 or lower. So if you run the command correctly, you see something like that. Now we are ready, and we can go to Unity side, open up this project folder in Unity editor. Next step is we have to go to package manager and install two these packages, ML agent and ML agent extension. They're already located on GitHub repository, so you can just install from disk, and the repository you already clone from Unity GitHub repository. So after installing this, easily you can just run ML agent learn, and this is how we start learning start machine learning in Unity. Python is connected to Unity. If you see this logo, it means everything is work fine. Head back to editor and press play. Yeah, this is starting using ML agent in Unity. So let's see. Let's start with Hello World project example for ML agent. We have a very, very simple project. We have a blue player. Player have to reach the goal, the green one, and also avoid the reaching red one. It's a trap. Also, if the player hit the walls, we reset the scenario. This is how our agent known to interact with our environment and reach the goal. First of all, after the steps I show you on the video, we create a simple script named simple agents, for example. Then we have to using unity.ml agent namespaces. These two automatically add to our project. If not, you have to add manually in your project. Then we have remove mono behavior inheriting for our class and inheriting from agent class. Everything for doing and learning your agent is located inside in this class. For the start of the project, we only need to override these three methods. First one is on action receive methods. It helps send data and actions for the agent, and agent decide how to behave with and interact with the environment based on values passed to these methods. The collect observation methods, actually our main methods. This is how Python observe our classes and see what's happening when make decisions or when the states are changed. On episode the cycle, so every cycle when beginning, we have to do things to reset this episode. Right, the code is here. So after creating this script and attach it to player, you see behavioral parameters automatically add, and here's our simple agent script. Also, we need to add a decision request component from ML agent library. So it's passed the data to our behavior parameters class and simple agent class. They pass data, and our agent start receiving and acting inside our environment. We have two types of the data for ML agents. They can be float or integer. For float, we have here in number 4 actions. In continuous actions, I define we need two float data type, one for x-axis and one for z-axis. I don't need integer and leave it just as it be. The created data type is integer. When I in branch size set it to 1, it means you have one value, just 0. Or if you set it to 5, you have 5 values, 0, 1, 2, 3, or 4. It's starting from 0, so notice that. It helps us to change in direction. If you have 4 direction, you can change it using the created data type. So after implementing and completing code, we have something like this. On action receive methods, we add player positions and receive continuous action on index 0 for x-axis and 1 index for z-axis. I also serialize the transform of the player, goal, and trap on this script, so I know where is the player, where is the goal, and where is the trap. I also have to add this to collecting observation methods to Python know and observe the position of this transform and see what's happening when make decisions. So we have to add sensors. Sensors that add observation, player position, goal position, and trap position. This is everything you need to implement ML agent for your project. It's very, very easy and very, very fun to developer when doing this. After that, on episode begin, we just reset the player position because every time the episode ending with a fail or win conditions, we have to relocate the player on the start position and start this scenario over and over again. One last thing we have to notice is setting the rewards for the agent. Agent without rewards is not working and can't train well. So we have 3 kind of tags: wall, trap, and goal. If the agent reach the wall, I set the reward to -1, and this is how agent know it is not a good behavior. So don't receive positive rewards. So I end the episode is here, so it's make the episode reset and start over again. Also, if the player hit the trap, I also set the reward -1. For the goal, I set the reward +1, and this is how agent know this is the target and things it should be follow. After implementing this on trigger enter, let's see how it look like when run. We run ML agent -learn to start train our agent. First step, we have to set ID with using this command, /run ID, and this is our test ID. As you can see, our agent start to try and move around our scene, and when hit the goal, the floor color change to green, and if they hit the trap, the floor colors change to red to see how visualize the result of the agent. We also can multiply the game object to speed up our training time. I duplicate this game object 20 times. To parallelly train our agent 20 times at the same episode. As you can see, our agent is start to learning on different scene. Let's see the result when we reach the checkpoints. After training on step 0, we don't see many green lights on the floors. We reached the 50,000 time. It's almost take 20 minutes for this example. You can see we reached the 1,000 step. 100,000 steps. The green lights are increasing. We set to train this agent 500,000 times. So when we're reaching 500,000 time of training, you can see the green rate of the floor are increased and red are decreased. So our agent learn how to reach the targets and try different scenarios. Now we are in this step, 250,000. The whole time of this processing almost take 2 hours. So we train the agent after 2 hours. We're reaching 500,000 step. As you can see, the rate of green follower are increased. Yeah, now our training is finished with 500,000 step. Then Python show the result for us. There is no error, and there is a Onyx file created for this training session. To use the trained brain, we have head to our environment folder. In this folder, result dash PPO, and the name we set on the beginning of the training. We have to manually add this file into our Unity project here and set it to behavior parameters. This is how we use trained brain inside the Unity. Let's see how it's happening in the video. We set the brain to behavior parameters, and only we need to apply to other prefabs and hit play. You can now use this brain for your project and see how it's act inside your main scene or interact with your player. As you can see, it is moving to target. If you ask yourself why its behavior weird and moving like that, because this is a very, very simple project and it's almost do nothing, just have 2 parameters to move on X and Z axes. We don't use floating or rotating value or smoothing the movement. So our agent is a little bit weird. But let's see the other component of the ML agent and see complex example. We have different sensors inside the ML agent component. In this case, for IO game, we use grid sensor. Grid sensor help the ML agent to monitor and see everything's happening inside the scene, and we gave the tag to this sensor, and agent can recognize and follow the other tags inside the scene. The example of this game is we have 5 agents that are trained 500,000 times. We have 2 kind of item, ice cubes and fireball item. If you collect 5 ice cube in row, you can shoot the ice and freeze other player. This is very complex example for implementation. It's almost take a day to implement this logic of ML agent and other sensors. We don't use, for example, we just use grid sensor. And we define all item tags inside the grid sensor. We just see the result. Here's the result after we train this agent. As you can see, there is many items inside the scene. They are trying to collect and avoid fire items. And when they reach or collect 5 ice, they shoot each other and try to freeze each other. As you can see, it's freeze. And also, they don't do everything right. Sometimes they collect fireballs and get negative rewarders. As you can see, these boats freeze each other at the same time. It is very easy to set up compared to old way to create this AI. Also, we have 2 other examples from Unity block. They are very interested. They are using another sensors like raycast sensors. Let's look at them. This is the interesting example Unity create. We have an agent. Agent have to reach the green goal. If the goal is this side, the agent have to push this white cube to the goal, or if the goal are other side of the wall, have to jump over the wall and reach the goal. As you can see, you can train a very smart agent inside your game. This agent using raycast precision sensor to detect every object around the agent. Yeah. Let's see another example. This is the team match game. For blue agent, matching against the four purple agent, they collect the ball and shoot each other, or cooperative can pass the ball to each other. As you can see, this is another example of implementing agent for IO game. Yeah. Let's see the conclusion. This is our experience using ML agent. We suggest that you can use ML agent for any IO games if you have to publish your game and you are in hyper casual fields. You can implement it easily for any racing game like cars, airplane, or ship racing game. You can implement it on sport games to play tennis, football, or basketball. There is tons of example to implementing like football or tennis game for ML agent. Also, you can use for P2P games. So player feel that he's playing with another competition online. Also, you can use ML agent for enemies' smart behavior inside your game. If you have maze or puzzle game or hide and seek game, you can use ML agent to chase or find the player and interact with player as an enemy. Also, you can use on board game like chess or Bagamon. And also, you can use ML agent to test your game functionality, because our agent uses the same functionality of the player we write inside our project. Here's our references to Unity technology in GitHub and website, and also CodeMonkey have a lot of learning video. You can watch them. They are very great. Here, how you can reach us and contact us, and if you like to have this presentation file, just send us email. I share this file with you. Thank you for your time. If you have any question, I'm here. Thank you. Yes?
How can you make your agents stupid?
Yes, you can actually in here. Here, you define how many action your agent should take. In this case, we just pass the two parameters for X and Z axes. Okay? Also, we have this part for giving reward. If you want to make your agent stupid, you have just change your game logic. Agent interact with your game, and if reach the goal, maybe you gave him a little bit less reward, or you can define the logic of movement or speed of movement here. So your agent's speed decrease, and actually you have to do it right here. There is where this method is where the component name decision requesters send parameters here. Also, we have the max step count. You can lower this max step, so when it's reached the end, ML agent start the scenario over and again. If you increase this max step, your agent become more smarter.
Thank you.
You're welcome. Any other questions? Thank you for your time.